everyone. Before we start the video, I just want to let you know something. You don't have to do this, but I would like you to subscribe and like, as it helps this video reach more people. Onto the video. This is kind of a follow-up video to the previous one, discussing a few things I didn't touch on earlier. Today we'll be discussing RAM. RAM stands for Random Access Memory, and we'll figure out why it's called that later. If we look at a stick of RAM, it doesn't look too complex. It's just a few black boxes. But those black boxes are memory chips. Let's take a look inside one. If we look deeper, it's made of multiple layers. But the one that's most important is the silicon chip, or an integrated circuit, IC. Inside these chips, there are hundreds of banks. These banks, when examined internally, are made up of thousands or millions of tiny capacitors, with transistors attached. Now let's look at the internal structure of one of these memory cells. It looks like this. There's a capacitor hooked up to a transistor. When we activate the bit line, it causes the transistor to allow current to flow into the capacitor, which then goes to the word line. But we need to remember that these are capacitors. Capacitors can only hold charge for a short amount of time, just a few seconds. In the case of DRAM, they can only hold charge for up to 64 milliseconds. That's really tiny, less than the blink of an eye, which is why they constantly have to be refreshed. There's circuitry that helps keep this refreshed. When we open up the bit line, it causes all of the capacitors in the bank to open, either allowing current to flow or not. Sensors at the other end detect these changes. If there's a change, it registers as a 1, and if there's no change, it registers as a 0. This data comes in a 32 or 31-bit format. The first bit is used for reading and writing, and the first 5 bits specify which bank the data is in. Most systems have up to 32 of these banks. The next 16 bits are for the row, and the remaining bits are for the column. When this data is passed into the RAM, it'll return 8 bits, the byte at that specific location. Everything gets constantly refreshed by other circuitry. And that's how RAM works. But why use RAM? Aren't there other forms of storage, like hard drives or SSDs? Well, now it's time for us to discuss RAM versus regular storage. Regular storage is mostly mechanical, unless it's an SSD. These storage types usually take a few milliseconds to access data, but that's too slow for the processor in a computer. That's where RAM comes in. Let's say you're loading a game. First, the game code loads into RAM, then it loads your save file, allowing the CPU to quickly access that data, about 17 nanoseconds compared to the 50 milliseconds it takes to access data from other storage devices. That's a huge difference. But even that's too slow for the CPU. That's why the CPU also has its own internal cache, which functions similarly to RAM, but it uses a different system. Instead of capacitors, it relies on transistors linked together. This design doesn't require constant refreshing like RAM does, and since it's internal to the CPU, it's much faster. Here's how it works. First, game data is copied to RAM. Then the necessary data gets copied into the CPU's cache. The CPU processes the data from the cache. If the data isn't in the cache, it looks in RAM. If it's not there, it'll search in the hard drive. But most of the time, the data will be in RAM. And that's why RAM exists and is so important. Anyways, goodbye. I hope you liked this video. Bye-bye. Hello everyone who actually made it to the end of the video. If you enjoyed the video, I would like to ask a favor of you. Can you please like and subscribe, as it helps this video get to more people. Anyways, goodbye.